Hello everyone, welcome to the lab 6 of electronics ELEC 2210, and this is all about diodes. So for the first step, that's the lead bridge, you need 2 red LEDs, 2 yellow and 2 green. And apart from that, you need one 330 ohms resistor and a power supply of 15 volt and the ground. So for the first step, the resistor is connected to a 15 volt supply and the other end is ground. So let's see. So as expected, the current flows from here through the green one, the yellow and the other green to ground. Now let's reverse the wires. Now we have just reversed the ground and the 15 volt supply. Now the current is in the opposite direction from the red to the yellow to the red to ground. Second step of lab 6, and that is the diode IV characteristics. Okay, so for the second step, the first thing that you need to do is make your connections. In the DMM panel, you can see COM. So take the COM wire and connect that to your banana B here. And then you have A, connect that to banana A. So first, it's the forward characteristics. So for that, we need the first connection, that is from COM to the diode. So this is coming from the COM to banana B to the diode. And then the other end of the diode, the cathode side, is ground, which is ground over here. Okay. And the other one is the banana A, which is coming from DMM A to banana A to the VPS positive, which is pin number 48. That is supply plus VPS. So after you make the connections, you go in and search LabVIEW 2018. Make sure it's LabVIEW 2018. Click on that. And you need to download the program over here. Just click on that and it would be downloaded. So over here, we'll go to open existing and then downloads and the one that you downloaded and click on OK. So this window will open up and you'll have your VD start at 0 and VD stop at 1. Number of steps 30, power limit 0.1, and let's click on play. That's run. So it will plot the forward characteristics. Once it's done, right click, go to export and export data to Excel. So this brings us to the end of the forward characteristics. So for the next one, that's the reverse characteristics, you need to connect banana A to your VPS supply negative, which is pin 50. And all the other connections remain the same. Now let's go and click on this one and your program would be downloaded. Click on open existing, reverse that program that you downloaded, click on that, click on OK. And now your VD start would be 0, VD stop would be -5 volts. go ahead and check it once over here. And then you can click run. So this brings you to the reverse characteristics. Right click and click on export and export the data to Excel. We are into step 3, which is the bridge rectifier. And for that, you would need 4 1N914 diodes. So this is the first, the second, the third, and the fourth. They are in a bridge connection. And apart from that, we need a 20 kilo ohm resistor in parallel with that bridge connection. Then we need a 7.6 microfarad, which we can make with two 3.3 microfarad capacitors and one microfarad. So that would be in parallel, and that would make 7.6 microfarads. So this is the bridge circuit. So the input of the circuit comes from the function generator. You can see it over here, function generator fgen, which is number 33. So we connect the wire from 33, which goes as an input to your circuit. To the input, we are giving from the function generator a 10 volt peak to peak voltage, which will produce 5 volts peak. So this is the midpoint of the two diodes. And from there, it will go to the function generator, which is pin 33 from the Elvis board. And the other end would be ground, which you can see over here. And next, we would need the oscilloscope wires from AI0 plus 1, which would be going to one end of the two diodes. The second one would be ground, since the other end is ground. AI1 plus, we would connect that, that's the third one. We would connect that to one end of the resistor, and the AI1 minus would go to the other end of the resistor. So this side is the positive side, and that one is the negative. So just keep in mind when you're making these connections, have a look at the diagram in your manual. Okay, once the connections are made, let's switch it on. You'll go ahead and search for function generator, and then the oscilloscope. So in the function generator, make it 10 volts peak to peak. Click on run. In the oscilloscope panel, for source, the channel 0 settings, click on AI0. For this one, AI1, make both enabled. Check these values and click on run. So you can fix that by clicking on edge. Now you can see it's the output of due to the capacitor, it's almost flatter because of the value 7.6 microfarads. Now let's remove one 3.3 microfarad, which will make it to 4.6. Now you can see the ripples are sharper because of less capacitance value. So this is few steps of step 3. Next, you need to calculate, you need to see the voltage output. Let's put this back in, and you need across the D2, that is this one. So for that, we'll move it here, and this one to the other side. And you can see this is the output that you are supposed to get. So this brings us to the end of step 3. Take screenshots. Don't forget to take screenshots with both 7.6 microfarads and 4.3 microfarads. In the bonus segment, after you have done the first 3 steps, the step 4 is for 10 bonus points. If you have time, you can go with that. For this, we need RC4558, which is an op-amp, one diode, a resistor, 1K resistor, and the connection wires. So in this op-amp, the first pin is your output pin, the second one is your negative input, the third one is your positive input, fourth one goes to negative 15 volts, and the eighth one goes to positive 15 volts. So you can see the connections are made. The green one is negative 15, the yellow one is positive 15. The input to this is from the function generator, which is the orange wire. The blue one is your ground, which we would need for the oscilloscope wires. And the negative input is from the midpoint of the resistor and the diode. So that is connected over here. In the board, you can see AI0 plus. AI0 plus goes to your op-amp pin number 3, and AI0 minus is ground. AI1 plus goes to your pin number 2 of your op-amp, and AI1 minus goes to ground. So this is by this you can see your input and your output. And for seeing it in the oscilloscope, we would need the AI0 plus, which comes to the third point, the third pin. The AI0 minus is grounded. AI1 plus comes to your pin number 2, and AI1 minus is grounded as well. So this is the connection. Let's switch it on and go ahead and search function generator. Let's give a peak to peak of 10 volts and run. Over here, AI0, AI1, both enabled. And let's click on run and fix that. So you can see the first one is your signal, that is the input signal from the function generator, the green one, and the blue one is your diode output, which actually trims this so that we can, if we want to see it properly, let's give it minus 2. So now you can see how in the negative part it's suppressed. Now let's see how this diode combination is acting as a super diode. For that, let's give a peak to peak of 0.5 and click on run. And let's change the parameters. Get back to 0. So you can see it's there, but yeah, if you give a -2, you can see it properly. And you can see over here, it is peak to peak is 500 millivolts, which means it's just 250 millivolts from here. So with this diode, we can actually measure that kind of voltage. Next step is we can use let's make it to 0. And we can use a capacitor, a 3.3 microfarads, and put it across the resistor. Now you can see how this changes. It's just like following the positive voltage and just going like that. So this is what the bonus question asks for. So take screenshots, give screenshot of your circuit, and you're done. Thank you.